All right, ladies and gentlemen, welcome to section 8.4 trigonometry. As always, pause to take notes as necessary. Trigonometry is the study of angles. What we describe as a trigonometric ratio is actually a ratio of two sides of a right triangle, and that ratio is related to the measure of one of the two acute angles. Technically, it does not matter which, it's just we give the ratio a different name. There are three trigonometric ratios: sine, cosine, and tangent. So we're familiar with the traditional concept of laying out a right triangle. The hypotenuse is, of course, the longest side, the side that is next to the angle, which we have labeled with the Greek letter theta. That's the common variable that's used to denote an angle, is the adjacent side, and the one that is not touching the angle is the opposite side. So we have the definitions of sine, cosine, and tangent, and those are the traditional three-letter abbreviations for sine, cosine, and tangent. Sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. And of course, the tool that you probably learned to remember this was SOHCAHTOA. Now, once we set this up, somebody usually says, well, hang on, there's another angle there, and you don't have that angle labeled, so what happens, if I actually care about that other angle? What if that's the one that I'm worried about? Well, okay, let's worry about that one. So if I'm worried about that one, then what happens is the sides that I refer to as opposite and adjacent have to switch. And once that happens, then, SOHCAHTOA holds true. Nothing has changed. It works exactly the same way. So the typical first problem that shows up when we talk about trigonometry is we're going to find sine, cosine, and tangent of our very favorite 3, 4, 5 triangle. So sine is, of course, opposite over hypotenuse. The opposite side is 4. The hypotenuse is 5. So sine of theta in this case is 4 over 5. All right, cosine is adjacent over hypotenuse, and in this case, that would be 3 over 5. Tangent is opposite over adjacent. That would give us 4 over 3. That's it. Very simple, very straightforward. Now, let's take a look at that other angle that's there, and let's give it a name. Let's call it phi, or phi, if that's the way you want to say it. Well, if I look at phi, sine of phi is opposite over hypotenuse, and opposite of phi is 3. So that's going to be 3 over 5. If I do the cosine of phi, it's adjacent over hypotenuse, and the adjacent side to phi is 4. So that would be 4 over 5. And tangent is opposite over adjacent. Again, that comes directly from SOHCAHTOA. So in this case, the opposite side is 3. The adjacent side is 4. All right, very simple, very straightforward. Now we're going to go back to a previous section that we looked at, the idea of the 30, 60, 90 triangle from section 8.3, and we are going to find the exact values for sine, cosine, and tangent of 30 degrees. So sine is, of course, SOHCAHTOA. We're going to say sine is opposite over hypotenuse. In this case, because we're talking about the 30-degree angle, that means s over 2s. So what happens to the s's? They cancel, and I'm left with 1/2. So the exact value for the sine of 30 degrees is 1/2. All right? So, okay, cosine of 30 degrees. Cosine is adjacent over hypotenuse. So in this case, that's radical 3s over 2s. Again, the s's cancel, and I'm left with the exact value of radical 3 over 2. And when I look at tangent, tangent is going to be opposite over adjacent, so that's s over radical 3s. The s's cancel. There's always a 1 left in the numerator, so that's 1 over radical 3. And thanks to the idea of having to rationalize, we rewrite 1 over radical 3 as radical 3 over 3. All right. Now, we can use our calculator, of course, to calculate sine, cosine, and tangent values for particular angles. And we haven't had to do that yet, so I'm going to wait a second before we get there until we actually get to a point where we have to talk about it. Right now, all we've done is write ratios, which does not require the use of a calculator. And we've found 3 exact values for 30 degrees. And as our next problem actually does involve 30 degrees, we could do it with these values, or we could do it with the calculator. Now, a couple things about the calculator before we move on. Number one, you should have buttons on the calculator that say sine, cosine, and tangent. Actually, it says sin, cos, and tan. Now, if those are not directly visible on your calculator, you probably have a submenu that says trig, and you can find them in there. Before you do that, however, you have to check the mode on your calculator. Now, this is different on every calculator, and it gives you a choice between degree and radian that you would have to select. You're going to want to select degree. Hopefully, in the basic trig that you've seen in the past, you've discussed this. If not, and if it's not possible for you to do this because we can't find those things in the calculator, then that is something that we'll discuss when we see each other. So let's move on and let's talk about what we actually use trigonometry for. Trigonometry is basically used for two things at this point, either finding the values for missing sides of a triangle or finding the values for missing angles. So let's start by finding the values for the missing sides. I'm going to start with x just because x comes first in the alphabet. Well, as I look at my only labeled angle of 30 degrees, I see x is opposite that angle. The use of the word opposite tells me that I'm either going to be using sine or I'm going to be using tangent. And I see that the hypotenuse is labeled as 15 degrees. So x is opposite. I have the hypotenuse, which is 15. So I just say, okay, sine of 30 is x over 15. Okay? Now, algebraically speaking, I want x by itself, so I multiply both sides by 15. And I have to calculate the sine of 30. This is where the calculator comes in. We should be in degree mode. We go into our trig submenu, we hit sine of 30, and boom, it comes out. Now you're probably saying, why does he have all those zeros there? And the truth is, for the purposes of this, I actually did not use a scientific calculator. I used a trig table, and trig tables are typically accurate to 4 decimal places. That's why I used it that way. Okay? Now, the beauty of this is you could just type 15 sine 30 into a calculator and hit enter, and boom, you get 7.5. You're done. So x is 7.5. That's our missing side. So when I look at y, and I have a choice now. So when I look at y, I could say, well, y is adjacent, and I actually have the value for x, which is opposite. So opposite and adjacent means tangent. But we don't like to do that. We don't like to work with what we've found unless we don't have a choice. We like to work with what we are given, and we were given that 15. So I say, all right, I want to relate y and 15. I want to relate the adjacent and the hypotenuse. That's cosine. So we say, all right, cosine 30 is y over 15. Again, we multiply both sides by 15. And again, I used a trigonometric table, so I got this decimal. But you have the exact value on the previous slide. You go up to your calculator, you type in 15 cosine 30, you hit enter, and boom, you get 12.99. So that's our missing side. Now you're going to notice I'm using equal signs. The reason I'm doing that is just to stay in line with the way the book writes it. Technically, they should be approximate symbols if we're rounding it all, but that's not something I want to get into in great detail right now. So let's just kind of expand on this a little bit. So as I look at the first triangle, the one with the 40-degree angle, I have the 40-degree angle, I have 9, which is the adjacent side, and I'm looking for x, which is the opposite side. Opposite, adjacent, that means tangent. So tangent of 40 is x over 9 because it's opposite over adjacent, SOHCAHTOA. I multiply both sides by 9. I type 9 tan 40 into my calculator, or I use a trigonometric table to get a decimal value. And I end up with an approximate value of 7.5. Now, I wrote 7.5519 because of that whole 4 decimal place thing I was talking about before. That's it. If you rounded that to 7.6, I'd be very happy. As I look at the second triangle, the one with the 18-degree angle, I see the adjacent side of 38 and the hypotenuse of y. This is a little different. Something's different here. Okay? Now what's going on is the variable that I'm actually attempting to find is in the denominator. So what happens is, in order to clean it up, I multiply both sides by y, and I divide both sides by sine of 18 at the same time. And I end up with this. I look sine of 18 up in my calculator, or excuse me, in my trigonometric table, or you type 38 divided by sine of 18 into the calculator, you hit enter, and we get about 122.9. And when it comes to the last triangle, the one with the 73 degrees, all right, I see Z is adjacent. And as I look at this, I realize the 38 in the middle triangle is in the wrong spot. That should be on the short side. But the truth is, I can't go back and edit the video right now. So please make sure to adjust that and put the 38 on the short side of that triangle. I apologize. In class, that will be taken care of. So okay, I'm sorry. We look at the third triangle, and I see Z is adjacent, and 2.7 is the hypotenuse. SOHCAHTOA, adjacent hypotenuse. So I say the cosine of 73 is Z over 2.7. Multiply both sides by 2.7. All right, I of course look up the cosine of 73 on my trigonometric table, or we just type it into the calculator, and we get the missing side is about 0.78. Now at this point, somebody's saying, well, hold on. Why don't you ever worry about the 90-degree angle? Why don't you say, hey, I want to take the sine of 90? No, it doesn't work that way. And the reason it doesn't work that way is because if you suddenly start dealing with the 90-degree angle, then the opposite side and the hypotenuse of the same side, it becomes a big mess. Those are not things that we are able to deal with right now. So we only take trigonometric ratios of acute angles. That is it. This only works for right triangles. Are there ways to deal with acute and obtuse triangles? Yes, but we are not prepared to discuss those right now. We need to understand the basics of trigonometry first. All right. Now I said trigonometry had two uses. One is to find missing sides. Well, we just did 3 examples of that. The other is to find missing angles. Now, the way we do that is by using what are referred to as inverse trigonometric functions. The whole idea is this, and I realize that I didn't animate these, so I'll just kind of explain it. If I have the sine of theta, everything in math has an inverse. It has something that undoes it. Addition and subtraction, multiplication and division, squaring and square rooting. Things that happen in Algebra 2 and pre-calculus that you haven't even discussed yet. But everything has something that undoes it. Trigonometric functions have inverse trigonometric functions. And the way that we denote an inverse trigonometric function is with that little -1. That is not an exponent. It stands for inverse. So that little sign with the -1 is read as sine inverse. All right, if you're using this on your calculator, it should be under the trig submenu. If you have dedicated trigonometric buttons on your calculator, usually you hit second or shift and it's above it, and that's how you get to the choice. Some older calculators do not actually use that -1 notation. They use what's called the arc notation. So instead of the inverse sign, it would be called the arc sign. But those are fairly old calculators that do that. In all likelihood, you're not going to see a calculator that does that today, just in case you happen to have that calculator. But we're going to use both notations just so that we get comfortable with it. So, okay, what's going on here? All right, we have sine is opposite over hypotenuse. Well, if I want to cancel out sine, I use inverse sine. But the first rule of equations, what you do to one side, you do to the other. So I have to take the inverse sine of both sides. On the left, sine and inverse sine cancel out, leaving us with the angle theta. So that basically tells us, hey, if you want to find the inverse sine, or excuse me, if you want to find the angle theta, you can use inverse trig functions to do it. And you're going to say, well, hang on, what if I can't use sine? What if I'm using cosine or tangent? Don't worry, all 3 trig functions have inverse functions. So let's move on and let's talk about this. And unfortunately, the animation is a little screwed up, so I have to actually put these numbers in here. Okay. Okay, so now let's start. We're going to deal with the triangle on the left, the one with the angle theta. As I look at theta, the 12 and the 9 are opposite and adjacent. SOHCAHTOA, that means tangent of theta is equal to 9 over 12. Right about now, somebody's going, hey, you can reduce 9 over 12. Guess what? Don't care. Doesn't matter. It works without reducing it. It's not a problem. So you go, okay, I want to cancel out tangent. So I take inverse tangent of both sides. Okay, take inverse tangent of both sides. We type inverse tangent of 9 over 12 into our calculator. We hit enter, and since we're in degree mode, it spits out 36.87. So right about now, if you haven't been having strange problems with your calculator, you're probably saying, I'm not getting that. I'm getting like, some decimal less than 1. Well, if that's happening, you're in radian mode. So we need to find a way to change it to degree mode. All right, that's simple. All right, let's move on to the second one. And remember, we have discussed that Greek symbol before. That is phi or phi. So as I look at that, 38 and 64, that's adjacent and hypotenuse. That tells me I'm using cosine. Hey, I want to cancel out the cosine. Great, inverse cosine on both sides. I called it arc cosine this time, just so we could get used to seeing that notation. And again, reduce 38 over 64? Nope, don't care. All right, type it into the calculator, hit enter, and we get about 53.58 degrees. We go to the last triangle with that funny looking fish symbol. That is a lowercase alpha. All right, alpha is the first letter of the Greek alphabet. All right, the truth is, when it comes to angle measure, common variables that are used: theta, phi, alpha, beta, gamma, delta. So at some point you will see all of those. So I see the 1 and I see the 2.7. That's opposite and hypotenuse, SOHCAHTOA. That tells me I'm using sine. All right, I want to cancel out sine. Okay, I take inverse sine of both sides. I type it into my calculator, I hit enter, and I get my angle measure. Now, always write down the trig ratio first. A lot of people look at this and they go, well, wait a minute, why am I writing sine of alpha equals 1 over 2.7? Why can't I just jump right to the second line? For that matter, why do I even have to write the second line down? Why don't I just type it into the calculator and get the answer? That's where mistakes happen. That's where mistakes happen. So for S and R track, this is where we're going to finish up. For honors, I am going to mention the fact that there are actually 6 trigonometric ratios. Okay, and the ones that we were not told about before are called cosecant, secant, and cotangent. And we already defined sine, cosine, and tangent. So when I look at cosecant, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. What we find is that cosecant is actually the reciprocal of sine, secant is actually the reciprocal of cosine, and cotangent is actually the reciprocal of tangent. Now, you are not going to find anything in the book outside of an extension exercise that uses these 3 extra functions, ratios, excuse me, but it is a good idea that you actually know what they are. Somebody's going to say, well, why would I bother to use that? Really, depending on where your variable is, you might feel more comfortable writing it as a cosecant. In pre-calculus, you'll discuss it in greater detail. So, as we finish up this video, your homework is, of course, on SchoolWires, so you can go on there, and that's probably where you found this video. Look it up and do your work from there. So we'll discuss what we have to when I come back. Hopefully you understood everything, and hopefully your calculator worked for you. All right, see you guys later.